Dr. B. Dhanasegar is working as a lecturer in Department of Information Technology, Anna University, Chennai. He finished his MCA from Urumu Dhanalakshmi College, Bharatidasan University. He finished his ME in Computer Science and Engineering from College of Engineering, Anna University. His areas of interest are multi-core programming and architecture, programming models, compiler, automata theory, cryptography, and algorithms. He is an expert in subjects like compiler design, formal languages and automata theory, analysis of algorithms. His research area is code generation for multi-core architecture.
Welcome to the UGC lecture series on computer science. So, we have the subject that is compiler design today. In the previous episode, we have seen that is the various types of translators. So, few of them are like interpreter, the compiler, then assembler, macroprocessor, preprocessor kind of translators we have seen, and also we have seen the various comparative studies also. So, where do you find interpreters are useful for us and where compilers will be really useful for us, and when a compiler will be faster and when interpreter will be faster. So, those things we have seen in the previous episode. And a very important concept of this topic available in the design of compilers is the various phases of compilation. As far as this episode is concerned, we are having the different phases of compilation. So, first of all, you should know that is what is the meaning of a phase, and normally we have another term called pass also. So, compilers translate the source program by using that is one or two number of passes. So, there is a possibility for even translating the program, that is your high level language program, into its equivalent low level language program by using a single pass also. So, what happens there is a pass reads a source program of one version and writes into another intermediate file or the target file depending upon the number of passes, but what it writes is another version of your another that is form of your program. So, it may reads a high level language program and it will convert it into some intermediate language and write it into a file, and maybe if you are having another pass, it will read the intermediate file representation and produces the target program into another file. That is going to be two pass compilation. But there are advantages in going for two pass compilation and few advantages even having in your one pass compilation also. But the number of passes is restricted by the, sometimes it is by the language structure. So, declarative programming languages, for example, if you are having a lot of declarations in your code and every program variable before its definition or before its use, it must have been declared, means then there is a need for collecting all the declarations available in the program before the translation starts. So, if it is the case, then a one pass compiler will miserably fail to collect the that is the various declarations available in your code before the translation. So, in that kind of situations, we will find it is very much useful to go for a two pass compiler, so that the first pass will do some amount of work on your program, so that the second pass will find it much easier to go ahead with the translation of the program. So, the problem with the declaration and its usage can be completely eliminated by constructing a symbol table during the first pass of your compilation, and in the second pass of your compilation most of the time it will try to refer this symbol table for any kind of clarification or any kind of data that it wants about the various variables available in your code. The symbol table maintains the entire collection of program variables, and if there is a need for checking what is the type of variable or how much is the memory required for that variable or what is the scope of the variable. So, all those things can be very easily identified from the symbol table by the consecutive passes of your compiler. But now there is another term which we call it as the phase. So, that is what we are going to study now, that is the various phases of compilation. So, phase is once again a transformation, or it transforms the code, but it is not expected that we must write the output always into a file. So, it transforms the code. For example, if you take the very first phase of the compilation, it transforms it into, that is your source program, into a sequence of tokens. But the sequence of tokens will not be written into a file. What happens there is the sequence of tokens will be completely read by the consecutive, that is successive, that is phases, that we call it as the syntax analyzer, which will make use of the syntax, that is a sequence of tokens to produce a valid parse tree. And the parser, after constructing the valid parse tree, it is once again not writing anything directly onto a file, but it will produce the intermediate language as per the syntax director translation specification and writes it into an intermediate file. So, we can say that 2 or 3 number of phases combined together form a parse, and we will find that the output will be written onto a file. So, a phase is somewhat simpler than a parse, and a phase is not required to write anything onto the directly onto the file. So, it transforms, but the transformation of your code or the source program or the transformation of the program which is produced by the output of your previous phase will be written on to, will be given as input for the next phase, and the next phase transforms, it will give the output to the next phase and keep doing until we find a phase which will be forced to write the output directly onto your that is your file. So, that is about the that is comparison in between your parse and phase. So, mostly we will be having 5 or 6 number of phases as far as compilation is concerned, but the conventional version of your that is your compiler structure includes only 5 phases, but sometimes it can even one more phase called semantic analyzer. So, it will be included in between your syntax analyzer and the intermediate code generator. So, here is the structure of your that is your compiler. This first it accepts the source program as input for your that is your lexical analyzer, and then the lexical analyzer transforms the that is program into sequence of tokens. The tokens produced by your syntax analyzer will be given as input for your that is syntax analyzer, and the syntax analyzer produces the output which is going to be used by the semantic analyzer, and the semantic analyzer does the job of producing intermediate code, and the intermediate code is subjected to that is code optimization, and the code optimization, this optimized code will be produced as input for your code generation phase, and the code generation phase will write the output into the that is object program. This is what the various phases of compilation. So, now we need to look into that is the various transformations happening in various phases of your compilation. So, what happens in the first phase and what has happened in the second phase, and etc. So, as far as the very first program is concerned, so it is going to be the beginning of your front end of your compiler. So, we can say the complete transformation is that is front end and back end of your compiler, or we will be calling it as analysis component or the syntax that is your synthesis component. The analysis component, it simply reads and verifies, and the synthesis component which will transform it into that is object code. So, what we will be having in the analysis component is we have the lexical analyzer, we have the syntax analyzer, and then we have the intermediate code generator. So, these 3 together forms that is your analysis component, and from their intermediate representation to the object version being produced will be transfer, or it is going to be your synthesis component, that it is actually doing the job of the transformation of your code from source program to the object version. So, the front end is always a time consuming process, it because of you just look at the lexical analyzer phase, it reads characters by character, because of every that is source program is completely carved into, or it is divided into stream of tokens, and the tokens are formed with the help of that is reading character by character and combining them together into pieces called lexemes, or we will be calling them as logically cohesive elements. So, a token is a logically cohesive element, and the token will be normally described by a pair, where it is going to be something like if you are having an identifier, then it will be called ID and comma. The second component is going to be an address which refers directly into the symbol table. So, what is the meaning of role of the symbol table here is, it will just record the various identifiers available in your program, so that they can be referred or used by the consecutive phases. So, any program which is given as input for your that is your lexical analyzer will be transformed into sequence of programs, sequence of that is tokens, and the tokens are returned as a pair, that is like ID comma that is going to be the pointer for the symbol table, and this ID is only a notation, but it is not referring exactly what is the identifier name. But what is the identifier name there is normally called as lexemes, or we call it as lexical elements. For example, if I am having an expression called sum plus that is sum plus a, then sum is an identifier, plus is an operator, and ID some another one is called a is another identifier. So what happens here is the sum will be transformed into a pair where ID comma 1 will be the answer, and plus will be simply returned as plus because it is a binary operator which is known to the compiler what is to be done for that. And the third one is going to be a. Once again, what will be returned for that is ID comma 2, where 2 refers to the exact identifier called a. Now what is the meaning of lexeme here? So the lexeme is the sum is lexeme and plus is lexeme and another one called a. So they are the actual components which are there as far as your program is concerned. So whatever we extract from your source program and we will be transforming it into that is a pair will be called as lexical elements, and the pair will be called the tokens, and the tokens are read by the syntax analyzer. So here we have the description about the lexical analyzer. So it scans one that is character at a time from the source program and divide it into sequence of characters, or we call it as logically cohesive elements called that is going to be tokens. And these tokens are normally classified into two types. One is called the class of strings and another one is called specific strings. So class of strings and specific strings. So we have the categories called keywords that is and operators. So keywords and operators, what they are actually called as, they are called as the specific strings, and then identifiers and constants are called the class of strings. So first you should know what is the difference, what is the need for differentiating them into specific string and class of strings. So in any programming language, you will find certain things are constant that cannot be changed by the programmer, and certain things it is completely left to the programmer to define. For example, you take the keywords. So for in the case of C language, we have a keyword called if, or we have a keyword another one called else. But can we redefine the meaning of these keywords? It is certainly not possible. So these keywords and another class is called that is your operators. So we have list of operators supported by the language, and we cannot go for redefining the meaning of these operators. Under service we go for operator overloading as what we do in C++, but that too it is not available in your C programming language. So whatever the compiler that is interprets the plus or minus will be, it cannot be changed by the programmer. The programmer has no role in redefining the meaning of the operators, or there is no role of programmer in introducing a new operator into a programming language like C. So they are all actually fixed. So we call them as specific strings. And where do they stay as far as your compilation component is concerned? So they will be staying in a table called static table, which will be normally implemented by using a binary search tree kind of thing. And when there is a need for verifying whether it is going to be keyword or an identifier, the compiler reads the token and it will be checking whether it is there in the static table or not. If it is there in the static table, automatically what will happen is it will say that it is going to be a specific string, and that too it is happening for even your operators also. Suppose if it reads a plus and which is followed by some other that is character or anything, character or a digit, then it can immediately identify that plus is going to be an operator which will be there in the list of operators for the language. So they are called specific strings. But another thing is class of strings. We can say that there will be a constant, there will be an identifier, and there will be a function name, and there will be an there is array kind of things. So what happens is, see, if you are having an assignment like x equal to 10, so this x can be any identifier, and then it can be that is like your 10 can be any constant. So x is going to be, it can be even replaced by y or anything. But what is the very important thing here we have to understand is the equal cannot be replaced by anything. X can be replaced by y, 10 can be replaced by 100 or 100.7, but equal cannot be replaced by anything. So the what can be replaced, or what are the places where we can go for a lot of substitutions? So they will be called class of strings, and all these will be stored into a table called symbol table. That is, your x will be in a symbol table and the constant will be in a table like that. So, that is what your specific strings and class substrings. So, we shall continue this after a short break. Welcome back. We have seen that there are two types of that is tokens. One is called the specific string and another one is called the class substrings. And now the question is all about how do you describe these tokens. So, if I am saying that an identifier, sum is an identifier, there is a rule for that is generating this identifier. Else cannot be an identifier, if cannot be an identifier, but sum can be an identifier, or it is total can be an identifier. So, A1 can be an identifier. So, you just look at the that is way we are differentiating them, and another thing is how we are first of all identifying them. So, for any identifier, the rule is going to be the first symbol must be a letter. It can be anything from English letter, that is A to Z, and followed by we can have the combination of letters and digits any number of times. It can be even 0 number of times also. At least one symbol must be there. So, that is what we have the pattern called L followed by, that is a letter followed by a letter or a digit 0 or more number of times. So, we call this pattern or this expression as regular expression. So, the token structure of every token in your programming language will be described by the that is expression called regular expressions. So, here also we use the regular expressions for describing the lexical constructs, that is nothing but your that is your tokens. And now the question is that is how will you differentiate that is the various this tokens, that is your we have keywords and we have another one called that is your the class substrings. So, for example, if is a keyword we all know, but whereas if I use if is equal to 10, then it is going to be wrong. So, if satisfies the pattern structure for an identifier, but if cannot be there. So, how it will be differentiated by the compiler is about that is it will be that is your all the keywords will be listed in the beginning as far as the pattern structure is concerned, and if there is a match for if with your L followed by L or D star, it will be checked initially with your whether it is going to be keyword or not, and if it is a keyword, it will be treated as a keyword, but not as an identifier. So, if wherever we see that it will be treated as an that is your keyword, but not as an identifier. So, if if is used in the context where an identifier is supposed to be used, so then what will happen is the compiler will detect an error and report it to the programmer. So, that is what how we are differentiating the keywords from your that is your conventional identifiers. So, if it is going to be an identifier, simply it will be going for storing it into the symbol table. So, that is what we are having. So, lexical analyzer installs the classes of strings type of tokens into the symbol table and returns the token identified to the parser as a pair having the token type and pointed to the symbol table. So, every token will be converted into a pair provided if it is going to be a class of strings type. But whereas in the case of operators, if you want, you can even return the operators as a pair, saying that first one it is going to be an operator, and second within the operator what operator it is. So, first it can be a keyword, and within the keyword what is that keyword, what is an index for the keyword. So, that can also be done, we can return a pair. But since we are having the keywords and operators already in your static table, there is no need of returning it as a pair. You simply return what is going to be the keyword or what is going to be the operator. The compiler can very easily identify that this is going to be a token of type specific strings, and this must be used in certain context like the statement beginning kind of things. Now, the token can be either it is going to be a specific string type or it can be even a class of string type. So, for every whether it is going to be a specific string type or the class of strings type, the compiler is having a set of regular expressions, and those regular expressions will be telling you that is whether it is going to be a specific string type of category or it is going to be a class of string type of category, and it will be doing the appropriate action for that. For every specific string, there will be an entry made into the symbol table, and the symbol table will manage everything about that. That is the symbols are the constants. But suppose if you find a token that is lexeme which does not fit into any of the regular expressions given in your language specification. That is, if you are coming up with a compiler for any language, for every token there should be every valid token, that is every recognizable token, there will be a valid regular expression. But now we find a prefix. Prefix means the source program content which is not yet that is converted into stream of tokens. That is what the prefix which is yet to be processed. So, if you find a token, if you find a prefix which is yet to be processed, and but we are not able to match it with any of the already listed regular expression, so then what you will do? So, in that case your compiler will be helpless and it will report an error to the programmer. So, a token that is, if you are finding some lexeme, that is a prefix from your source program which is not yet expanded or not yet that is processed, is not matching with any of the already listed regular expressions, then it will say that some error has been happening. So, that is what we find, that is your structure of a compiler is always associated with the two additional components. One is called the symbol table management and another one is called error routines. So, symbol table management, it does the job of installing something into the symbol table, as well as installing as well as updating attributes for the symbols. In some phases like the intermediate code generator or even the code optimizer or the code generation phases, they will be reading the attributes from the symbol table with respect to some identifier. So, what is the role of the error management, that is error handling routines here? So, whenever you are, as far as your lexical analyzer is concerned, whenever it finds that a token is not recognizable or not a valid one, then it will report the error to the error management routine and it will take care of the reporting of the error to the programmer. We have some error recovery routines also. So, what the compiler does normally is, whenever it finds an error, that is, it will detect the error, it will report the error, and then it will recover from the error and it will continue compilation of your rest of the code. But that is not true as in the case of your interpreters. So, the interpreter, once it finds an error, it will report the error to the programmer and it will wait for the programmer to complete the correction of the error, and so that it will be able to continue the compilation of your code. But whereas in the case of your compiler, it finds the error, detects error, immediately it will report the error to the programmer. So, the programmer finds the error and it is not going to stop the error, that is your compilation process there, it will recover from the error and continue with the error. So, we have some error recovery routines. So, they will be will be used by the compiler to find out the way in which it is recovering from the error. So, the major things being done by any lexical analyzer is like identifying, that is the class of string type of token or the specific string type of token, installing it in the symbol table, and whenever it finds that it cannot have a valid token from the input program, it will report the error. So, the next phase is the syntax analyzer. So, which will be your syntax verification of your code. So, every source program is having a stream of tokens, but the stream of tokens, for example, if I am having an expression called a plus b, a is a valid token, plus is another valid token and b is another valid token. But if we give it as a plus b, it will be considered as a valid expression, but if I give it as a followed by b followed by plus, and it is not going to be a valid infix expression, maybe a postfix expression, okay, but if you are looking for infix expressions as far as a source program is concerned, then a plus b must be available in the order a followed by plus followed by b. Even though we have 3 valid tokens, we find that it should be available in the order a followed by plus followed by b. So, who defines this order? The syntax analyzer uses the grammar for describing this structure of your programs statements. So, it is going to be the syntax analyzer or parser, we will call it as always parser. So, which accept the sequence of tokens returned by the scanner and verifies whether the tokens are in the pattern that was permitted by the source language specification. So, the source language specification is very important. So, for example, in some language like in the Pascal, there is an assignment operator called colon followed by equal, and in C language we have there is simply an equal statement, and it is differing for different languages. Similarly, the expression syntax, C expects that every statement must be terminated by a semicolon, but that is not true in almost all the languages. Certain languages it is going to be a dot, and certain languages there is no delimiter for your plus or semicolon, nothing will be there. So, if you find that a statement is not terminated by a semicolon in C or C++, it will be an error, but it is not true in that is your Fortran kind of languages, basic Fortran kind of languages, there is no full stop or semicolon there. So, now the question is, the job is how this syntax analyzer verifies that. It makes use of the grammar will be used for describing the syntax of every programming language. For example, if you are having an expression, the syntax for the expression is going to be an expression plus another expression, or expression multiplied by another expression, or any that is binary operator, or it can even be an unary operator. In that case, the unary operator followed by an expression. So, this is what the general syntax for your expression. It will be recursively defined, and later stages we can end up with by saying that an expression is any identifier or a constant. A is an expression, and that is then 5 is that is an expression, since it is going to be a constant. So, all these are described with the help of your that is your syntax, your grammar syntax. So, but when there is an error, so what will happen is the parser represents the tokens in a when there is no error, it is represented in a parse tree or derivation tree kind of things, and when there is an error, it will be reported to the programmer. So, that is what about the syntax specification of your that is your syntax analyzer. So, what we have studied so far is the various phases of the compilation, and the various lexical analyzer, how it is scanning the tokens, and the syntax analyzer, how it is verifying the syntax of the source program. So, those things we have seen. So, from the questions component, there is one important question is what is going to be a token and what is a lexeme, how do you differentiate them, what is a parse tree, what is going to be a regular expression, and how the syntaxes are described, that is how the grammar will be written, or how we are coming up with the derivation tree. So, how errors are handled. So, those things are the possible questions, and the remaining phases like the intermediate code generator, code optimization, and the code generation phase we will continue in the next class. So, with this I complete this episode. Thank you all.